Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the radiation force on a disk due to a point source. Now, we have assumed that there is a point source S which is kept at this point, which is at a distance of, let's suppose, L from the center of the disk, and this source is emitting spherical wavefront going away from the source, and that wave front is passing through this disk and it is applying some radiation force on the disk. Now we obviously know that at all the points this angle will be different and r will be different. Therefore we have to integrate this expression. So to integrate, we first of all we assume a strip which is a ring which is of width dx, and the radius of the ring is x. So we have already studied that radiation pressure is when light is obliquely incident on any surface is I by c into cos square theta into r plus 1. This we have already studied previously and you can refer to that video. So this is the radiation pressure in the case when radiation is obliquely incident on the surface, and therefore we can say that the force acting on this disk, on this element which is a ring, will be df, and df will be radiation pressure P into area of this element, which is 2 pi x dx. So this will be I by c into cos square theta. This angle is phi, so let us take it as phi, and r plus 1 into 2 pi x dx. Okay, now this is very important to note that let us first of all write down the force df again. So df is I by c cos square phi, I by c cos square phi into r plus 1 into 2 pi x dx. 2 pi x dx. Now we know that due to a point source emits a spherical wavefront. So due to a point source, the intensity at a distance of r is P by 4 pi r square, where P is the power emitted by the source and r is this radius of this spherical wavefront. So the intensity due to this source at this point will be P by 4 pi small r square. So we have to consider this intensity also. So it is P by 4 pi r square c and cos square phi, and this is r plus 1 into 2 pi x dx. Okay, so this is the expression first of all. Now we know that this x by L is tan phi, so x is equal to L tan phi, and dx will be equal to L sec square phi d phi, and cos phi is equal to r, this is L by r, cos phi is equal to L by r, so r is equal to L sec phi. So substituting these values, df will be equal to P upon 4 pi c, r square will be L square sec square phi, and in the numerator this is cos square phi into r plus 1 into 2 pi x. X is L tan phi and dx is L sec square phi d phi. So cancelling this sec square and L square and cancelling this 2 pi with this, so df will be equal to P cos square phi into r plus 1 into tan phi into d phi divided by 2c. This will be the force. Now we obviously let us write it down again. df is equal to p cos square phi by 2c, p cos square phi by 2c, and into r plus 1 tan phi d phi, and r plus 1 tan phi can be written as sin phi divided by cos phi, and this is d phi. So cancelling this and this, so it can be written as p by 4c r plus 1 into sin 2 phi d phi. What I have done, I have multiplied and divided with 2, and I have written 2 sin phi cos phi as sin 2 phi. Okay, so now the net force F will be equal to p by 4c into r plus 1, where p is the power emitted by the source, and sin 2 phi, integration of sin 2 phi d phi, and the limit of phi. Obviously the limit of phi will be from 0 to this angle, and this angle, let us first of all draw. This angle is, let's suppose, phi naught. So the limit will be from 0 to phi naught. Okay, so f will be p by 4c into r plus 1, and integration of sin 2 phi is cos 2 phi by 2 with a negative sign, and f will be equal to p by 4c into r plus 1, and this is 8c. So it would be 0 to phi naught, so it would be cos 2 phi naught minus 1, and in fact we have used that negative sign, so it would be equal to 1 minus cos 2 phi naught. 1 minus cos 2 phi naught. Now we know that we will further simplify this expression. F will be equal to p into r plus 1, p into r plus 1 upon 8c, and we can write down cos 2 theta. We know the identity that cos 2 theta 2 phi is equal to 2 cos square phi minus 1. So it can be written as 2 cos square phi naught minus 1. Okay, so f will be equal to p into r plus 1 upon 8c, and we'll be taking this as common. So this is 2, and this would be equal to 1 minus cos square phi naught, and this is sin square phi naught. We could have used that identity directly, so it would be p upon 4c into r plus 1 and sin square phi naught. Okay, we could have used the identity directly, and this is sin phi naught will be r upon under root r square plus l square. So sin phi naught will be r upon under root r square plus l square. This is capital R. So force will be p upon 4c into r plus 1 into r square upon r square plus l square. This will be the force acting on the disk due to that point source. Thank you.